So okay, let's begin. I'm going to speak in English just because I don't know the technical words in Croatian, so hopefully you guys can understand me. So a quick word about me. I'm Marko Lukša. I'm an engineer at Red Hat, basically working on bringing JBoss middleware software to OpenShift. So that's the platform made on top of Kubernetes, which we're going to talk about today. I'll just skip that because it doesn't matter. So the old way of doing things, how we brought software to production without using Kubernetes and OpenShift. So how many of you have used Kubernetes or OpenShift? Oh, nice, okay. But was this the previous version, so version 2 or version 3? You don't know. So the previous version wasn't based on Kubernetes. It was our own solution. So now we rebased it completely on. Oh, right. So okay. So we all know that there's a lot of problems because there's a difference between our development and production environments, right? So it works on my machine. It doesn't work in production. There are the usual way of doing things is you build stuff and then you hand it over to the operations team or the system administrators, and they basically deploy your software, right? You always need to ask the administrators for help with anything regarding the production machines and so on. But on the other hand, then the system administrators need to know all the peculiarities of each of the application, and there's usually a disconnect communication barrier, right, between the developers and the operations team. And the cloud is big, obviously, so deploying to the cloud usually means that you can't easily transfer your software to another cloud provider, right? And then there's another thing. So our hardware is usually really not utilized as it should be. So kind of like our brains, supposedly we're using just 10% of it, right? So that was a myth, I guess. So it's the same with hardware. So the numbers are around 10%, I guess, for how much of how well we can utilize the hardware, right? And of course, everything's going global, so you need to have your options open in order to scale, because that's what enables business growth. So if you can't scale, you're gonna stand still, right? So the new way of doing things. I guess you've all heard of containers, Docker stuff. How many of you use it? Okay, like 30, 40%. So, but how many of you use it in production? Oh, nice, because the numbers are going up. So we all know what containers do. I can tell you those that don't. So containers basically allow you to isolate your application and run it as if it were running inside a virtual machine, although it's much more lightweight because containerized process is basically just a process running on the main operating system, but it's isolated from all the other processes, right? Unlike a VM, which basically is its own operating system and so on. So, and we're moving to microservices, and that brings a lot of additional problems because then you need to you have multiple software processes that you need to manage and connect them between each other and so on. So, plus the trend is now to move towards DevOps, which means that the developers and the ops team basically work together all the time, right? But that means that the developers are now forced to know the hardware infrastructure and know about the individual machines and so on. So actually, I as a developer don't want to know about specific servers, right? So I just all right. Yeah. So containers. they help alleviate, now it works. They help alleviate a lot of our problems, right? So it brings us a consistent environment for our applications. They allow us to package our application plus everything the application needs and into a portable package, which can then be used on any machine running the container runtime, right? So either Docker or Rocket or things like other things, right? So it allows us to store our application in a central registry, access it from anywhere, run it anywhere, as long as it's a Linux machine, right? They allow us to pack many more applications onto a single machine, right? Because there's less overhead. It all started with Docker, well, actually started before that, but Docker is the company that made Linux container technologies popular, right? Because they enabled an easy way to package up the application and share it across machines, right? Now there's Rocket, and there's an open container initiative which is trying to standardize all this. So isn't that enough, right? Because it solves most of our problems, right? So do we need anything else? So I guess we do, because otherwise Kubernetes wouldn't be as successful as it is. So Kubernetes is basically a Greek word for helmsman, so the person who actually steers the ship, not the captain, but the one who steers the ship, right? Or a pilot or an airplane, like, let's say. So why is everyone going crazy about Kubernetes, right? So I guess it's because it was developed by Google. It was based on two or maybe even more their internal systems they used. So the first one was Borg, and then they improved it, created Omega, and so on. So Kubernetes takes a lot of the best stuff from both systems and upgrades them. Obviously, Kubernetes is open source. It's being adopted incredibly fast. So actually, in a meeting I had just a few days ago, it was mentioned that the velocity of the core project is actually too big, so it's going too fast. So that's why they're trying to move the development of additional stuff into additional plugins and repos, so as to be able to stabilize the Kubernetes core, right? And Kubernetes is not just container orchestration, so it's not just something that orchestrates your containers across the machines, right? It's a lot more, because what Kubernetes does is it abstracts away the infrastructure. So let's say you have tens or hundreds of machines, right? Either virtual machines or bare metal. And what Kubernetes does is it presents all those machines as a single machine, right? So it allows you to say, I want to deploy my app, and I don't need to care about the individual machines. I just give Kubernetes my app, and it's going to run it on one of the machines or multiple machines, right? And I don't actually care where it runs, because it makes no difference if it runs on machine A1 or machine B3. It doesn't matter, right? Because, yeah, I'll get to that later. So, and what it also does is it does the operations work for you. So, where previously the operations or guys or system administrators, right, had to pick a machine to run your software and make sure there are no weird interactions between your applications, right? Kubernetes does that itself. So it finds the best machine to run your application, and that's it. And it also takes care of self-healing. So if your application dies, it's going to restart it automatically. If the node dies, it's going to move all the applications that were running on that node to the other healthy nodes. So you don't need to do that. So the system administrator doesn't need to do that at like 3 a.m. in the morning, right? And it also takes care of auto-scaling. So if the load on your applications increases, it's going to increase the number of replicas, so number of, let's say, application instances to meet the new demand. And then when the load goes down, it's going to scale down. So, what does Kubernetes bring? So I've already talked about scaling, self-healing, and so on. So there's also other things, right? Kubernetes is able to pack your applications really densely onto your machines, right? So what this means is that in the end, you can use way less machines than if you weren't using Kubernetes, right? So instead of, let's say, 10 servers, you may get off by using just 6 or 7, right? Because it's able to mix and match the applications so they all fit on the machine, right? It also does automated deployment rollouts and rollbacks. So when you do a new version, it's going to automatically roll out the version. You don't need to take care of that manually, right? Yeah, that's the most important things, yeah. So self-service app deployment, what it is. So basically how Kubernetes works is that the system admins, right, just install Kubernetes on all of your machines, right? And then the developers are able to run their own apps without talking to the system admins, right? Or waiting for them, right? So basically the developer talks to Kubernetes, tells it that I want you to run X copies of this application, and it's gonna run it, right? So, and then the user can later remove those copies and so on. So, yeah, I've already talked about the other stuff. So, okay, maybe the last point. So the system administrators don't need to take care of the apps anymore. They just take care of Kubernetes, and Kubernetes takes care of the apps, and the developers also do. So it's a lot more friendly to system administrators and on developers because they don't need to wait for anyone, right? So the architecture of Kubernetes is really, it's really simple to me, but maybe for first-time users it's not as easy. But basically we have a master server usually, which can be spread across multiple servers and replicated for high availability, right? And the master server basically runs the distributed key value store, which stores the metadata for your cluster for all your applications, right? It runs the API server, which is used to talk to the to Kubernetes, right? It runs the scheduler, which determines where each application should run, and then there's a bunch of controller processes which do the actual work, right? So, yeah, and then actual work of taking care of the cluster, right? And then there are nodes. And these are the nodes that actually run your application, right? Because the master doesn't run your application, the nodes do, the worker nodes do. So each worker node has a container runtime. It can be either Docker, Rocket. It has the kubelet, which basically talks to the container runtime. And you have the Kubernetes proxy, which takes care of communication between your applications, right? So they can easily find each other, regardless of where they are. Interacting with Kubernetes looks kind of like this. So the developer prepares a YAML or JSON descriptor of the system they want running, right? Sends that to Kubernetes master, and Kubernetes then runs all these applications on some of the nodes, any of the nodes. You don't know which ones they are. You can check, but you shouldn't care, right? So the Kubernetes uses the declarative approach instead of an imperative. So you don't tell Kubernetes run this or increase the number of instances by 2, right? You just tell it the state you want the system to be in, and then Kubernetes will look at the current state of the system and the desired state of the system and perform any changes that need to be done, right? This is really great because let's say if one node goes down, if they were using the imperative approach, then you'd have to tell Kubernetes what to do at that point, right? Whereas when a node goes down and Kubernetes is using the declarative approach, did I say declarative before? Yeah, I should have said imperative, yeah. So Kubernetes sees that there's a difference between the actual state and the desired state and just fixes it, right? So you can either talk to the REST API directly. There are lots of client libraries for lots of languages, or you can use the command line tool to start, right? And it looks kind of like that. You use kubectl run, define the name of your deployment or application, right? Define the Docker image or Rocket image that should be running, right? And the number of copies you want to be running, right? The second command, for instance, exposes, let's say, the 3 replicas I'm running, so 3 copies of my application are running somewhere in the system, and the second command makes them available on a single IP address on a single port, right? Because the copies obviously can move around the system in cases where when a node goes down, it's going to have to migrate it, so it gets the application gets a new IP, right? Whereas the expose command creates a static long-term IP for the bunch of applications, a bunch of copies of the application running in the system, right? You can list pods, deployments, services, whatever. So any objects you can list with the kubectl get command. And then you can scale up or down with a simple kubectl scale, name the deployment name, and then tell it the new number of replicas you want, and it's going to take care of replicating. Yeah, I'm getting late. I'm going to skip the concepts. So let's switch to OpenShift. So Kubernetes doesn't build your code, so build your apps, right? Whereas OpenShift is built on top of Kubernetes and also allows you to build the app and deploy them automatically once they are built. So OpenShift is an open source platform built on top of Kubernetes. It also builds app, as I said. You basically don't need to deal with Docker because you can just point it to your Git repo, right? And it's going to build your app. You don't need to build your Docker images yourself if you don't want to, right? So OpenShift is open source. You can download it, run it right now. But obviously, we also have products like the OCP, so OpenShift Container Platform, which you run on your own machines. We have OpenShift Dedicated, which means we run OpenShift and give it to you so you can use it, right? So it's on our machines running, and then it's OpenShift Online, which is free for all, basically, for anyone wanting to try it. We also provide a bunch of templates and container images for all our middleware products, right? So that's the thing my team does right now. Yeah. Okay, I'm going to skip that. Let's just go to the demo because we're running late. So what are we going to do? We're going to deploy an application in JBoss EAP, so basically Wildfly, right? It's going to run inside OpenShift. We're going to scale up the number of instances to 3. So we're going to actually have 3 EAP servers running the same application, right? We're going to simulate a node going down by deleting one of the pods, then do an update of the app, the rolling update will be performed automatically, and then we're going to scale down and clean up everything, so if we get to that. Yeah. I have a video, so nothing can go wrong. So basically, this is the this is the OpenShift web console, right? So the developer basically logs into it, and then they can start to create a new project and then run the applications inside it, right? So I'm going to start a project called Javantura. And then it gives me a list of all the available products or basically Docker images that are available in OpenShift, categorized by language. We're going to choose JBoss EAP, right? Because we're going to deploy an EE application. We have lots of versions, and we have different templates. So this is what our team does. There are a lot of combinations, so EAP plus Postgres, EAP plus MySQL, and so on. We're going to run the basic template, which uses an internal database, so inside EAP itself. It doesn't use an external one. So I've now chosen the template to use. Now I can enter my application name. I'll just leave it as it is, right? I'm going to enter the URL, so the Git repo of where my application is stored. And the branch where it is stored in. And this is a quick start project which has a lot of applications, and I need to specify the subdirectory which holds my actual application, right? There is a bunch of other parameters I can set. So these are per template. Each template has its own bunch of parameters, and then you just click create, and it starts going to work, right? So what it's gonna do right now is it's gonna clone the GitHub repo and start building the application inside it. It's a Maven application, so the builder image, which takes care of building, right, detects what kind of application it is. So if it sees a pom.xml, it sees it's a Maven application, and it starts a Maven build, right? We can check the logs as the application is building. So it's downloading all the artifacts because the build is running inside a Docker container, right? So there are no Maven artifacts downloaded yet, but then you can use a Maven mirror to speed up the process, right? There's also a CLI interface for OpenShift and Kubernetes, right, which allows you to basically do anything that the console does, the web console does. In this case, let's say we can see the builds that are going on. So there's a single build. It's been running for 52 seconds. And we can check the status with the OC status command, which also tells us that the build is running and a deployment is waiting for the image or update to the configuration of the deployment itself, right? Yeah. So I'm going to skip forward to the end of the build right now. And as soon as the build completes, the deployment is going to be initiated. So what that means is that the build process builds our Docker image, it puts it into a registry, right? It has been pushed successfully, and now the deployment sees the new image and starts up our application. So it's going to start up a pod. A pod is basically kind of like a virtual machine, but it's actually just a bunch of containers that are in the same namespaces. So to them, it seems as though they are running on the same machine, even though there's lots of other projects or applications running on the same machine, right? But the containers inside the pod are isolated in the same way that applications on a virtual machine would be, right? So the EAP has started already, right? It's now running, and we can now check to see if our application is actually responding to requests, right? So a URL has been created for our application, and here it is, right? So this is an application running inside the JBoss EAP, running inside OpenShift. So on one of the nodes somewhere, right? Because I don't care where it is. This is a 4-node cluster, but I can see the node where the pod is running at, right? Obviously, I can SSH into the container to check whatever I need to check, right? So the standalone deployments directory includes the root.war, which was built by the build process, right? So now we have a single instance running, and we're gonna try to, okay, just to show you the pods. So pod is basically like one machine, right? It has its own IP. It can talk to all the other pods, because you see, so each pod has its own IP, and each pod is on, so these two pods are on two different machines, right? But one has already completed. So one was the build pod that actually built the application. So how can I scale up to 3 instances? It's easy. It's as easy as clicking on the up arrow, right? So now I've told Kubernetes that I want 3 copies of my application to be running, and it's gonna see that there's only one. So it obviously needs to run 2 additional ones, and that's what it's going to do. And we already have 3 pods running, whereas, so the first one, this is the old one, is already ready, and the 2 new ones aren't ready yet. So basically, it's not gonna expose the 2 new pods, 2 new instances to the outside world until they are ready, right? So one is already ready, and the other one is gonna be ready in a couple of seconds. so you don't need to take care of that yourself, right? The application tells Kubernetes when it is ready to serve clients, and Kubernetes then puts it into service, right? So basically, right now I'm hitting 3 different servers running somewhere in my cluster, right? So now I'm gonna simulate what happens when one of the nodes goes down. I'm gonna delete one of those pods, right? So this is one EAP instance running somewhere. If I delete it, right, what's gonna happen is, so the pod is terminating and another one has been created automatically. So no matter what happens, maybe a newbie developer accidentally deletes one of the pods, right? It doesn't matter because Kubernetes is going to take care of it automatically. So a system administrator doesn't need to be on top of that and doesn't need to run an additional copy because it's taken care of itself. So again, we have 3 pods. One isn't ready yet because it takes a while for the EAP to start up and so on. Okay, so now I'm going to show you how an application update looks like. So I'm going to change the background color of the application, right? Push this to GitHub. Yeah. Yeah. Yeah, but of course the application needs to support that. So that's the hard part. Yeah. Especially, let's say if you're using let's say distributed data storage, right? Basically, that's a really hard problem for us to solve. Alesh was solving it for AMQ because once you tell Kubernetes to shut down a pod, it's just going to shut it down. It's going to send it a termination signal. Then it has like 30 seconds to finish, which is usually not enough to transfer data. So you need to do something else. Before I do the update, I'm just going to change the definition of my deployment. So this is the YAML I was talking about. I'm just going to change the strategy used to update the application. So instead of a recreate strategy, which basically stops all the previous version pods, right, and starts new ones, I'm going to tell it to use a rolling update strategy. So this means the max surge and max unavailable parameters basically tell it to, it can go from 3 to 2, but then it needs to go back to 3 again before it can kill another pod, right? Another previous pod. It's going to be shown in the process. So I've just started a build. You can obviously add a webhook into GitHub to have the build started automatically. So basically, as soon as you commit a new version to Git, it's going to start building it automatically, right? So it's building it again, and at the end, it's going to deploy it, and it's going to do it in a rolling fashion, right? So this is our 3 old pods, and the new pods are getting created right here, right? So it's scaling the old, it's called a replica set, so it's the old one to 2, and there's a new one created, and it's scaling it up to 1 for now, right? And as soon as the new pod is ready, it's going to scale the previous replica set to 1 and increase the number of replicas in the new one. So it basically does it in a rolling fashion, right? So the application is available all throughout the upgrade process. It's never unavailable to clients. But of course, the application needs to be able to cope with running different versions. So if you have a data store behind it, that's your job. Kubernetes doesn't take care of schema migration and things like that, right? If your application can handle running 2 pods, so the old version plus the new version, right? You can specify the strategy so it first starts the new pod, and when that is ready, it takes down the old one, right? Or you can do it like I did, so I can deal with one replica being missing. So I know that 2 replicas are enough to handle all my load, right? So, but it's configurable, right? But it's up to you to prepare the application so it's ready. It can support all these strategies, right? So now we have 3 pods. 1 isn't ready yet, and if I refresh, I'm going to see the new version. Nothing spectacular here, right? Um, there's one more thing I'm going to show. I just need to remember what it is. Oh yeah, scale down. So it's easy to scale down even in through the CLI, right? I'm just going to scale down my EAP app to a single replica. We see the 2 pods terminating while another one is still running. This shows that 1 pod running, and that's it. So just to finish everything, now I'm just going to delete everything, right? Because it's self-service application deployment, so you also need to be able to clean up after yourself if this is a test environment, for instance, right? Not in production. So, oh, there's the thing. So if you need to add an autoscaler to have it scale automatically, you can basically just click and say, I want to add an autoscaler to my application, and then you specify the minimum number of pods, maximum number, and the CPU target. So all the pods will need to be around 80% CPU. That's the target. So if there are if the actual CPU usage is higher than that, it's going to scale up. If it's lower than that, it's going to scale down, right? So this is the autoscaler. And I think that's it. Just to clean up, it's really simple. Just delete the whole project, and that's it. Or keep the project and delete the objects we created in the beginning, right? So delete the pod, delete the services, and so on. Yeah, so that's it. One last thing. I'm the author of Kubernetes in Action, so if anyone's interested, please buy it. I've set up discount code, which I believe was also mentioned at the keynote. It's for all Manning books. It's going to be valid for around 2 weeks, I guess. So that's it. Thank you.